Bonjour, good morning. I'm going to show you how you can work through the problems for your assignment for Tuesday. This is what it should look like. You're going to start. You can see you've got 10 questions. And when they're asking about a rational or irrational number, you guys learned about that yesterday in the videos that you watched. Rationals are going to be like the repeating decimals, and irrationals are going to be the decimals that go on forever and ever and ever and never stop. So these three dots here tell you that it keeps on going forever. They obviously cannot just have it go on forever for this question. So you need to realize those dots mean it goes on forever. It is an irrational number, okay? Click that. Good job. And then you can go to next. Okay, which numbers are irrational? So what you're looking for here with these square roots, if it's a perfect square and it's something like 10 times 10, then it's not going to be irrational. So we're not going to pick that one. 20 is not a perfect square. You can't take two numbers and multiply the same number by itself and get that. So that is going to be irrational. 56, 7 times 8, but that's not the same number. So that is going to be irrational. 64, this is 8 times 8. So that is a perfect square. So we're not going to count that one. So let's check and see if we got those right. Okay. Now, these ones are asking for you to find rational numbers, okay? So you're going to look at each one and you are going to decide if it's a rational number or not. Anything that's a whole number is rational. So we're going to click all the whole numbers, whether they're positive or negative, okay? So we've got the whole numbers. Now we have to decide about these fractions. So when you have this fraction, you want to see if it's a repeating or if it goes on forever, you're going to use a calculator. And we are going to say 19 divided by 8 equals, okay, this does not repeat forever, it stops. So that one is a rational number. This one is repeating. If it's a repeating decimal, it's rational. So we can choose that. Pi we know is irrational because it goes on forever and ever. Let's try 7 over 4. Let's use our calculator. And let's go 7 divided by 4 equals 1.75. Okay, it's not a repeating. It terminates, it stops. It doesn't go on forever. Here we go. So these should be, okay, I'm looking for a problem here that's going to give you a repeating decimal that might round, okay? So now let's see here. We're still looking for rational numbers. Are there any numbers that you can multiply by themselves to make 40? No, that one's not rational. This goes on forever. It has the 3 dots. That's not rational. Whole numbers, yes. Whole numbers, yes. Whole numbers, yes. 7 over 5, we need to divide that and see what happens, okay? So let's go 7 divided by 5 equals 1.4. It stops, and that means it is rational. Which numbers are rational, irrational? Oops, this one says rational. Okay, so this one is rational. So what I wanted to show you, and it hasn't happened yet, is that sometimes when you have a repeating decimal and you do it on a calculator, it might do like, it might show you something like when you do the dividing, it might go like this, and then it'll fill your whole screen up, and then at the very last one, it'll be rounded up 1. If this happens and you think like, oh, well, wait a second, what does this mean? It just means that they can't show you that 3's go on forever and they don't have that little notation for the line above it on your calculator. So at the end, they just rounded it just to show you. So this would just be a repeating decimal. It doesn't really turn into a 4, okay? Just wanted to show you that. So work through these problems, and when you get to the end, you should be able to turn it in. Let's see what happens. Might look different for me than for you because I'm a teacher. Submit my work. That's, yep, okay. So that's what it should look like for you, okay? All right, guys, good luck. If you have questions, just let me know.